So this is our second video, and then for this video it will cover until example 7. Okay, so let's continue with our videos number 2. Composite events. So we have two diagrams here. The first one is the intersection of A and B, and then the second one is the union of event A and event B. Okay, so A and B and A or B are two examples of composite events. In the set notation, A and B is just the intersection of A and B. So this is the intersection of A and B, while A or B is the union of A and B and represented by A union B. So the second diagram is for A union B. The sum of events. The sum of multiple events is a set of outcomes that includes all outcomes from all of the events. So the sum of events is actually the union of the events. The probability of the sum of two events, for example, we have event A and event B, is usually stated as the probability of A or B. So for the sum of event, we will have this word or. Okay. So if event C is the sum of event A and event B, then we know that C here is the union of A and B. Okay, so C is equals to A union B. Done with the sum of events, we go to the joint event. So the joint event of multiple events is a set of outcomes that the multiple events have in common. The joint event is the intersection of events. So if we have these two events A and B, for example, and if we want to talk about the joint probability of these two events, we are talking about the probability of A and B. So we will have to use this word "and" to represent the joint event. If event C is the joining of event A and event B, then C here is equals to A intercept B. So done with the union event and the joint events, let's talk about the probability of the sum of the events, or addition law of probability. Okay, so if we have two events, again, the probability of the sum of these two events to happen is this, as in the diagram. Okay, so if we have event A and event B, and if we talk about the union of these two events, it is actually event A plus with event B. But then don't forget to minus the intersection of these two, event A and event B. Hence, the addition law of probability is PA union B is equals to PA plus PB minus with PA intercept B. Example 5, we have a fair die is roll once. So we want to find the probability of getting a number less than 5, an odd number that is less than 5. So this is the joint events. And then an odd number or a number less than 5. So this is the union. So I will use bot because to solve this, because we don't have enough space here. So let's look at the solution. As mentioned earlier, we will have this blackboard to write our answer for example 5. But before we proceed with the answer, we have a fade die rolled, so our sample space is 1, 2, 3, 4, and 5. And we know that our number of outcomes for a die is 6. Okay. For question A, we want to find the probability of getting a number less than 5. So let's use X to represent that event. And for X, we want to choose any number that is less than 5. So that is 1, 2, 3, and 4. So the number of outcomes here is 4. Hence, the probability of getting a number less than 5 is nx over ns, which is 4 over 6. Simplify, we will get 2 over 3. So that's for question E. For question B, we want to find the probability of getting an odd number. So let's use Y to represent that event. So any odd number for a die is 1, 3, and 5. And we know that the number of outcomes here is 3. Hence, the probability of getting an odd number is ny over ns, which is 3 over 6. And if we simplify this, we will get 1 over 2. So this is the answer for question B. Let's continue to solution for question C and D. So for C, we have x intercept y, and the number of outcomes is 2. Hence, the probability of getting an odd number that is less than 5 here is px intercept y, which is nx intercept y equals to over our ns, so equals to 2 over 6. Simplify, we have 1 over 3. That is for question C. For question D, we have the union for x and y. But as we have A, B, and C previously, and all the answers, we can use addition law of probability, which is px union y is equals to px plus with py minus with px intercept y. So previously for px we have 2 over 3, and then py we have 1 over 2, and px intercept y is 1 over 3. Hence our final answer is 5 over 6. Example 6, we have a class of 40 students where 5 out of the 15 girls and 7 out of the 25 boys are members of the Mathematics Society. So we choose a student randomly and we want to find the probability that the student is either a girl or a member of the mathematics society. So this is the union events, and we will have to use the addition law of probability. But before that, let's choose G to represent the event of a girl, and let's choose M as the event of the person is a member of mathematics society. So let's write that first, member of mathematics society. From the question, we have probability of all the girls in this class is 15/40. And then we also know that probability of all the members in the mathematics society in this class is 12/40. We add 5 and 7 there, become 12, and out of all the students we will have 12/40. And then the last info that we need is probability of a girl and also a member of the mathematics society, which is PGNM, or the interception. PG intercept M is 5/40 because we have 5 out of the 15 girls are the members of the mathematics society. So PG intercept M here is equals to 5/40. Now for PG or M, we use the union PG union M. By using the addition law of probability, we have PG plus PM minus with PG intercept M, which is 15/40 plus 12/40 minus 5/40, and our final answer is 11/20. So that is the solution for example 6. Done with example 6. Now let's look at example 7. A total of 655 persons have multiple jobs in a city. Of them, 381 are male, 299 are married, and 168 are male and married. So find the probability that a randomly selected person with multiple jobs is male or married. So before we proceed with the number of outcomes and the probability, let's use X to represent the event of a male is selected. And then I want to use Y for an event where a married person is selected. So once we have this X and Y, we know that our NS is 655 and X is 381 and Y is 299, and NX intercept Y, male and married, is 168. Okay, continue. Now we want to find the number of outcomes for X union Y. So just use the formula of addition. So we use nx plus ny minus with an x-intercept y. So we have 381 plus 299 minus with 168, where we get 512. Hence, for the probability of X union Y, means the selected person with multiple jobs is male or married, is nx union y over our ns, which is 512 over 655. So that is our answer. Okay, so we're done with example 7, and then let's take a little break before we go to video number 3.